How's it going, everyone? In this video, we're going to go over how to perform basic operations, mathematical operations, plus, minus, divide, multiply, with complex numbers. So when we're talking about complex numbers, we're talking about numbers that have an imaginary component. So often complex numbers are written as u plus iv. Now, I is the square root of -1. That's what complex numbers are, where there is a square root of a negative number involved. So first I'll tell you, well, you can't take the square root of a negative number because any number multiplied by itself will give you a positive result, right? Like -3 squared, well, that's going to be -3 times -3, which is +9, just like 3 squared gives you +9. So you can't find the square root of -9. And that's why imaginary numbers were defined. Okay, so the square root of -9 can be written as the square root of -1 times 9, which is going to be the square root of -1 times the square root of 9, which is going to be I times 3. That's what I is, the square root of -1. So, as another example, the square root of -16 would be I times 16, or it could be written 16i. That's what complex numbers are, and they do have a number of applications. In this video, I'll just talk about how to do basic operations with complex numbers. And a complex number could have an imaginary component and a real component. So, for example, 3 plus 2i, or you could write it 3 plus I times 2, that's a complex number. Its real component is 3, and its imaginary component is 2. So let's say you just have a number 4. Well, you could say that its imaginary component is 0 because that equals 4 plus 0i. If you have 3i, which is the square root of -9, well, you could say that its real component is 0 because that's 0 plus 3i. So, how do we add and subtract these? Well, let u plus vi be one complex number, and a plus bi be another. Okay. Well, u plus vi plus a plus bi, it's just like collecting like terms. You add the real components, u plus a, and you add the imaginary components, plus v plus b I. Right? You're just factoring out the I. So, for example, 3 plus 2i plus 5 plus 6i, well, that's going to equal 3 plus 5, which is 8, plus, how many i's do we have? 2 plus 6, 8i. And that's that. Now, if we're dealing with subtraction, well, that's just adding a negative, right? So let's say we have 3 plus 2i minus 5 plus 6i. Well, that's fine. That's just going to be 3 plus 2i minus 5 minus 6i. We do the same thing. 3 minus 5 is -2, and 2i minus 6i is -4i. right? So whether you're adding or subtracting, because subtraction is just adding a negative, you collect the like terms. You add or subtract the real components, and you add or subtract the imaginary components. Now, what happens if you're multiplying? Okay? So what if we have u plus vi multiplied by a plus bi? Well, it's just like you would open up any brackets, right? You'd multiply u times a, u times bi, vi times a, v times b, or vi times bi. So what we have is ua plus ubi plus vai plus vbi squared. Now we can simplify this. ua, just multiplying the two real components. Here we can factor out the i's. So we have ub plus va times I. And then we have these imaginary components multiplied, vb, but we have this I squared. Now what's I squared? That's negative 1. Because remember, I is the square root of negative 1. So I squared is the square root of negative 1 squared, which is negative 1. So we can further simplify this. ua plus ub plus va times I minus vb. And here we can rearrange this to have a more easy to look at real component and imaginary component. The real component is ua minus vb, right? The product of the real terms minus the product of the imaginary terms. And then the imaginary component is ub plus va, okay, which is the product of a real term times an imaginary plus the other real term times the imaginary. Okay? Now it looks like a long formula, but it's really just opening brackets, right? So if we have 3 plus 2i multiplied by negative 5 plus 4i, you're just multiplying these brackets. Okay, so we have 3 times negative 5, negative 15, 3 times 4i plus 12i, 2i times negative 5 minus 10i, and 2i times 4i is going to be plus 8i squared. Now remember that I squared is a negative 1. So we actually have negative 15 minus 8, right? That's that right there. That is a minus 8 because I squared is negative 1. Plus 12i minus 10i, and we can simplify that further. So we have negative 23, and then plus 12i minus 10i is going to be plus 2i. And that's our answer. Right? So the formulas can seem to look long, like this right here, but the answer is just an ordinary looking complex number. Your real component, your imaginary component. Same with here, right? That looks like a long expression there, but it comes down to a rather short, ordinary looking complex number. So we did addition, subtraction, we did multiplication. The only thing that's left is division. That's where it gets a little tricky, but still elegant. So let's say we have u plus vi divided by a plus bi. So here we're going to make use of something called the conjugate of a complex number. Every complex number has a conjugate which is equal to a complex number with the same real value but a different imaginary number. Specifically, the imaginary component is multiplied by -1. So the complex conjugate of a plus bi is a minus bi. Okay? So for example, 3 plus 2i has conjugate 3 minus 2i. Okay? 5 minus 6i has conjugate 5 plus 6i. Right? These are pairs of complex conjugates. And here's where that comes in useful. We're going to take u plus vi over a plus bi, and we're going to multiply that by the complex conjugate of the denominator, a minus bi divided by a minus bi. Now here's what the result is. So we multiply the tops the way we would multiply complex numbers. ua plus ubi, sorry, that's minus ubi, plus vai minus vb times I squared, divided by a squared minus abi plus abi minus b squared I squared. Now look what happens at the bottom. So at the top, well, our I squared right here becomes -1, which combined with this -1 becomes a positive, right? So we have ua plus vb minus ubi plus vai. And in the bottom, we have a squared. And notice that these terms cancel out because it's something subtracting itself. The I squared is -1, which with this negative becomes a positive, so we just have a squared plus b squared. The bottom is now entirely real. It's also equal to the squared magnitude of that complex number. And we won't get into that because that has to do with graphing complex numbers, and that'll be the subject of a different video. So we can simplify this, and we have ua plus vb, and then we have plus the imaginary component, va minus ubi, whatever ends up on top, divided by a squared plus b squared, which is just the sum of the squared real and imaginary components of the denominator. The trick is just multiplying top and bottom by the complex conjugate of the denominator. And again, it looks like a long formula, but it's just opening brackets. So for example, let's say we have 3 plus 2i divided by 5 minus 4i. Okay, we multiply top and bottom by the complex conjugate of the denominator, which is going to be 5 plus 4i. 5 plus 4i. And that's what's going to guarantee a real number in the denominator once we open these brackets. So we have 3 times 5, which is 15. We have 3 times 4i, which is 12i. We have 2i times 5, which is 10i. And we have 2i times 4i, which is 8i squared. Then in the bottom, we have 5 times 5, which is 25. And we have, well, 5 times 4i, so plus 20i, negative 4i times 5 minus 20i, and it's going to cancel out, so you can even skip writing that down. And then we have minus 16i squared. Okay, now what happens when we simplify that? Okay, so remember, that's a negative 1, so we have 15 minus 8. So we have 7 plus 22i on top. At the bottom, this cancels out. This negative 1 turns this minus into a plus, and we just have 25 plus 16. Now you could go from here straight to here in terms of the denominator, just because you see, oh, it's a complex number multiplied by its conjugate. That's just going to be the real part squared plus the imaginary part squared. Right? So you could go straight there. And we keep going. So we have 7 plus 22i divided by 41. Right? Because we have 25 plus 16, which is going to give us 41. And so we have 7 out of 41, or 7 over 41 is our real component, plus 22 over 41i is our imaginary component. So even though, if you think of it as a formula, it's a complicated looking one, when you just realize that, oh, we're just multiplying top and bottom by the complex conjugate of the denominator, you work it out, simplify everything, and it just looks like an ordinary complex number where you have a real part plus the imaginary part, and that's it. So that's your basic operations with complex numbers. I hope that helps, and until next time.